Hello everyone. I welcome you to this lecture on the NPTEL course Advanced Thermodynamics Introduction to Molecular Simulation. Right. So we'll just wait for a couple of minutes for other people to join in. Okay, and then we'll start. In the meantime, if you guys have any doubts, you can ask it. Right. I hope you can see my screen. Yeah. Okay. I hope you guys can see my screen and also my face. Yeah. So we'll just wait for a couple of minutes for other people to join in. Let's say we'll wait till 7:05. And in the meantime, if you guys have any question, you can ask, or we can just wait. Okay. Okay. So let us start. So I again welcome you all to this lecture on NPTEL the NPTEL course. Advanced Thermodynamics, Introduction to Molecular Simulation. So my name is Varad Dav, and I'm a doctoral student here at the Department of Chemical Engineering, IIT Kanpur. Okay, so let us begin. So does anybody have any doubt related to previous classes? Yeah, if nobody has any doubts, then we'll move on to the next question. Yeah. Not the next question, the first question of the class. So, like I said, in the previous class, we have studied about Hamiltonian and Lagrangian equation of motion, and we are going to continue. We'll first start with that, and then we'll have one question on that, and then we'll have very very quick one short question on quantum mechanics, a couple of such questions, and then we'll delve deeper into our lattice models, which we have been taught. So we'll solve extensively many problems based on lattice, how to find the partition function, or how to find the thermodynamic properties using this based on models for this lattice lattice way. Okay. So depending on the time, whether either we'll finish all of the questions in today's class, and if time permits, and if because of some issues we are not able to do it, then we'll move on to then we'll cover this in the next class. Okay. So let us first go with the first question. So the first question is, if H is the Hamiltonian, then if H, which is the classical Hamiltonian, does not depend explicitly on time, then we have to show that the first derivative of this Hamiltonian with respect to time is equal to zero. Then we are also asked to find what is the physical significance of this, that is dH by dt is equal to zero. And if this is true, then H does not explicitly depend on time. Okay, let us write. Let me write this down, and then we'll discuss. Okay, if H D, which is the classical classical Hamiltonian does not depend on time, then we have to show that dH by dt is equals to zero. And then the second part of the same question is, what does this mean physically? What does this mean physically? And again, the third part would be, if this is true, is this true if H does not explicitly depend on time? Is this true if H does not depend on time? Right? So I hope the question is clear to everyone. If you have any doubt regarding the question, you can ask me, and I'll give a couple of minutes. Let's say 3 minutes, 3 to 4 minutes for you to solve it, and if and then I'll try to solve it. Okay. So just try to understand the problem, and then try to attempt the question. Anybody able to solve the question? Oh, you need time? Okay. I'll go. We will wait for a couple of minutes. Okay. So let us try to solve this question. So let me first read the question again. So if H, the classical Hamiltonian, does not depend on time, then we are asked to show that dH by dt is equals to 0. And what is the physical significance of this result? And is this true if H does not depend on time? Right? So let M1 be the mass of, or Mi, let Mi be the mass of the ith particle, and R1 be its position. R1 be its position, and Ri dot, that is the first derivative of position with respect to time, be its velocity, where Ri dot is nothing but d by dt of Ri. Right? Now we know that Hamiltonian is nothing but the total energy, whereas the Lagrangian was the difference of the energies, right? Is the total energy, which is nothing but kinetic energy plus potential energy. Therefore, that is equals to summation of summation over all the particles, right? Let us assume that there are n particles, right? Half of kinetic energy is what? Half of mv square, and here velocity is given Ri dot square, plus potential energy is what? U of Ri, right? Where kinetic energy equals to half mv square, which is half of mi. So here it should be mi, right? Mi into Ri dot square, and potential energy is equal to U of Ri. Okay. Now let us assume that this is expression one. So different, which is nothing but half of mi into d by dt of Ri and his square. Differentiating. Now let us differentiate this equation. That is, let us try to differentiate this expression. That is equation one, so that we get dH by dt of the LHS, and then we'll solve for the RHS and see what result we get. Okay. So differentiating, creating equation one with respect to time. Therefore, we get d by dt of h is equals to d by dt of summation I is equals to 1 to n half of mi into ri dot square plus u of ri, right? That means dh by dt is equals to d by dt of summation I is equals to 1 to n half of mi into ri dot square plus d by dt of u of ri, right? Now here we see that the mass of the particles are, let us assume, okay, let us first write that dh by dt is equals to, so mass of the particle is going to remain the constant, right? This is going to be mi, right? So this is going to be nothing but summation I is equals to 1 to n half of, so its derivative dmi by dt is going to be 0, right? So it is going to be mi into d by dt of ri dot square plus d by dt of, and what is this, u of r1 r2 up to rn, right? What does this sense? This tells us that dh by dt is equals to half of mi, right? Summation, let me rewrite this, summation I is equals to 1 to n half of mi into 2 times ri dot multiplied by d of ri dot by dt, right? Plus d by dt of u of r1 r2 up to rn, right? So this implies dh by dt is equals to, we can take half outside as is the constant, I is equals to 1 to n mi. So actually this gets, or let me write this like this, 2 will also get outside, right? Outside the summation, summation I is equals to 1 to 1 into mi into ri dot into ri double dot, right? Plus here we'll do a slight modification, d by dri into of u of r1 r2 up to rn multiplied by dri by dt, and does the test. This tells us that dh by dt is equals to, this thing gets cancelled, right? So we are left with summation I is equals to 1 to n mi into ri dot into rn double dot plus plus, so what is this? This is going to be nothing but the force, right? Derivative of potential is nothing but force. Derivative of potential with respect to coordinates or with respect to position is nothing but force Fi. Hmm. With respect to Fi, this implies dH by dt, right? So let us write this down, right? So we'll write this down that dH by dt is equals to summation I is equals to 1 to n mi into Ri dot into Ri double dot plus is nothing but force, right? That is going to be negative of force, right? Going to be negative of force. Hence here we'll write minus Fi minus F. Let me just write this down. So here we will write minus of F minus of F into Ri dot, right? Now why? Why? Since dRi by dt is nothing but Ri dot and d by dri of u of r1 r2 up to rn is nothing but my negative of force, right? Therefore what we have is dH by dt is going to be nothing but, so we take ri dot as common, so ri dot into summation I is equals to 1 to n mi into ri double dot minus force. But what is this? But mi is equals to mass of atoms and Ri dot is equals to acceleration, because this is equals to d2 Ri by dt square. Therefore what we can write, dH by dt is equals to, before that, right? And what is, and then summation I is equals to 1 to n summation I is equals to 1 to n mi into Ri dot is nothing but summation of I is equals to 1 to n mass into acceleration, which is again going to be summation I is equals to 1 to n of force, right? Therefore summation of I is equals to 1 to n mi into Ri double dot is going to be nothing but summation of I is equals to 1 to n force acting on ith particle, which is going to be nothing but total force, right? Total force. Therefore let me use a different pen now. Therefore dH by dt is going to be what? Ri double dot multiplied by total force minus F, which is going to be Ri double dot into 0, which implies that dH by dt is equals to 0. Hence proved. So does anybody have any doubt in this question? I'll give you a couple of minutes to ponder over, and then after, if nobody has any doubt, then we'll move on to the next question. So we'll wait for 5 minutes. That is till 7:30. So nobody has any doubt. If nobody has any doubt, then we'll move on to the next question. We'll just wait for 1 more minute and then we'll move on to the next question. Okay, so let us move on to the next question. Okay. Okay. We'll just wait for a couple of minutes so that I can. Yeah. So this is the first question. This is the next question. Question number two. Quite easy question. What is the fundamental function? What is the fundamental function? Let's say that is x of natural variables s, p and mu, both in differential form and integral form. Differential form and integral form. So the hint, so I hope the question is very clear, and you should have no trouble in understanding the question. Uh, so I'll give a couple of minutes for you to solve, and then I'll solve the question. Okay. So we'll just wait for a couple of minutes for you to solve this. Okay, and then I will solve it. So let us solve the question. Okay. Solution. Solution. Okay. So now we know that h of SPN is going to be nothing but LV of, that is SVN, right? And we also know that DH is equals to TDS minus, sorry, plus VDP plus mu DN for open system. For open system, right? Now let us assume that X, which has been given, it is some fundamental variable of SP mu. So what we will need to do is we would need to do Legendre transform. Here H is SPN. So let me write this down in a very systematic manner. That H of SPN, if we do Legendre transform, then what we'll get is we'll get that S P mu, right? So hence we can write, hence we can write that H of SPN is going to be Lagrangian of H of SPN. Here it should be mu. So now let us take Lagrangian multiplier. Okay, this is nothing but H of SPN star minus C into N star, where C is equals to dou by dou N of H of SPN at SP and n equal to n star, right? That is number one. The other is x of s p mu is equals to Lagrangian of, right? Again writing the same thing, s p n star, which is equals to h of s p n star minus mu n star, right? Taking total derivative, we get, right, d of x s p mu is equals to d of h, which is a function of s p n star, minus d of mu into n star, right? Which is nothing but dh of s p n star minus mu dn star minus n star d mu, correct? Therefore dx of s p mu is equals to tds plus vdp minus n star d mu. What we have is dou of dou by dou s of x of s p mu at p mu is going to be t. Okay. Similarly, dou by dou p of x of s p mu is going to be v, and dou by dou mu of x of s p mu is going to be n. Okay. And the integrated form is the integrated form of the equation is x of sp mu is equals to p into s plus v into p minus n into mu. The final answer, which we can see, is answer. Final answer is fundamental function x of sp mu in differential form is d of x sp mu is equals to tds plus vdp minus n d mu, and integrated form of the fundamental form is x of sp mu is equals to ts plus vp minus n into mu. Okay. is the final answer. I hope the question and solution is clear to everyone. If anybody has any doubt, they can ask. We'll just wait for a couple of minutes for everybody to digest this fact, and then we'll move on to the next question. The question is clear to everyone. All right. So let us move on. Let us move on to the next question. Okay. The next question is also quite simple. So going to the question number 3. It tells us that for a system, so the canonical partition function has been given, and we are asked to find the corresponding equation of state. Okay. So let me write down the question. For a system, hmm, for a system, we have the following expression for the canonical partition function. Canonical partition function, right? And the partition function is like this: q of n b beta is equals to 1 by n factorial into 2 pi m by h square beta whole to the power vn by 2 into p minus nb whole to the power n multiplied by exponential of beta n square by p, where a and b are constant. We are asked to find, derive the corresponding equation of state. So what we are given, we are basically given a partition function for a system, and clearly this beta is going to be nothing but a function of temperature. That is, it's a Boltzmann factor 1 by kBT. That is already known. This is a canonical partition function, as this is a function of NVT, right? And the partition function has been given, and what we are asked is, we are asked to find the corresponding equation of state, right? So I hope the question is clear to everyone, and I'll wait for a couple of minutes, let's say 5 minutes, for you to solve it, for you to attempt it, and after that I will solve it. Okay. So we'll wait for a couple of minutes for you to attempt. So is anybody able to solve this question? Anybody got what is the corresponding equation of state? Okay, we'll wait for a couple of minutes. Sorry. And let's solve the question. Okay. Okay. So what we are given is, we are given Q as NBP is equal to 1 by n factorial into 2 pi m divided by h square beta whole to the power 3n by 2 multiplied by b minus nb into exponential of beta an square divided by b, right? Where a and b are constant. Now taking log on both the sides of equation 1. Again, where this is the equation 1. So what we get? Log of q of nv beta is equals to log of the entire expression, which is what? 1 by n factorial multiplied by 2 pi m by x square beta whole to the power 3n by 2 into v minus nb into exponential of beta an square by v. Right? Now we know that log of a into b is equals to log a plus log b. Therefore, log of q and v beta is going to be equal to 1 by log of n factorial plus log of 2 pi m by h square beta to the power 3n by 2, right? Plus log of v minus nb plus log of exponential of beta an square by b, right? This implies that log of q of nv beta is going to be minus of log of n factorial plus 3n by 2 into log of 2 pi m by h square beta plus log of b minus nb plus beta an square by v, right? So using Stirling's approximation, which is log of n factorial is nothing but n log n minus n. Right? We get log of q, which is a function of n b n beta, is equals to minus n log n plus n plus 3n by 2 ln, no? Right? It's not log, it's ln. Here also it will be ln everywhere. ln 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 ln. Here everywhere it will be ln. Here it will be ln ln and ln. Yeah. So ln of 2 pi m by h square beta, correct? Plus ln of b minus nb plus beta an square by v, correct? Now we know that A, which is Helmholtz free energy for canonical ensemble, is nothing but minus Helmholtz Helmholtz free energy, which is nothing but A, which is equals to minus kBt into ln of partition function, which is here q of nv beta. Hence, we can write that A is equals to minus kBt into, let us call this as number 1 using equation 1. If A is equal to minus kBt into ln of that value, which is minus n ln n plus n plus 3n by 2 into ln of 2 pi m by h square beta minus 3n by 2 ln of beta plus n ln v minus nb plus beta an square divided by v. Right? Now again, let me use a different color. Now we know that. So let us call this as expression 2. Okay? We know that P is equal to minus of dou A by dou V at constant T comma n, right? Hence, taking partial derivative of equation 2 with respect to V, we get dou by dou V of A at constant T comma n is nothing but minus KB into T, or let us write this down, is equals to dou by dou v of this entire term minus n ln n plus n plus 3n by 2 into ln of 2 pi m n to h square beta minus 3n by 2 into ln of beta plus n ln v minus nb plus beta an square by v. Now this has to be at constant t comma n, and as soon as we incorporate this we get dou a by dou v at constant t comma n becomes minus kbt into 0 plus 0 plus 0 minus 0, all the terms except this one become 0, and v minus nb into 1 plus beta a by n square into 1 minus v square, as beta is equal to 1 by kbt and t is equal to constant, right? Therefore what we get is the whole complex looping equation becomes a very easy one, minus kbt into n by v minus nb minus beta a n square divided by v square, right? We multiply both the sides by minus 1, hence we end up with minus dou a by dou v at constant t comma n becomes equals to kbt into n by v minus nb minus beta a n square by v square. Now from, but this is going to be equal to, we know that ratio is nothing but minus dou a by dou v at constant t comma n. Hence, ratio is going to be kbt into n by n minus vb minus beta n square by v square. Resubstituting, beta is equal to 1 by kbt. Therefore, what we get is, if we write this down, therefore, ratio becomes equal to 1 by beta, 1 by beta into n by n minus nb minus beta a n square by v square. This is the required equation of state, right? So I hope this is clear to everyone. So I'll just give a couple of minutes for you to digest it and understand it. If anybody has any doubt, they can ask me. Mhm. I hope this is clear to everyone, but we'll just wait for you guys to understand it, and then uh, let me give you 5 minutes. Anybody has any question? We'll just take a break of 5 minutes, so that if anybody wants to go to drink water or want to go washroom, they can go. And in the meantime, if no, if anybody has any doubt, they can still ask it. So it's 8:10. We'll come back at around 8:60, 8:16 to 8:18. Okay, so we'll move on to the next question. Okay. The next is a very big question. So I will write the question. So this is the fourth question. Okay. So I'll first narrate the question and then we'll then move on to the then I will write down the question. So the question is quite a big. So first we'll start with a small question. Okay. So consider a system having n sites and the system has q particles. These particles can either have upspin or downspin. The energy of interaction is given by epsilon is equal to some constant into sigma square, where W is a positive constant and sigma is the spin, which could be +1 and -1. Now, if the number of if n0 is the number of vacant location, like a vacant positions, n up is the number of particles having upspin, and n down is the number of particles having downstream downspin. Then what and q is equals to n up plus n down, and m is equals to n up minus n down. Then find the following. The first is the number of microstates and hence the entropy. The second, the temperature of the system. And the third, comment on temperature calculated in part B. Okay, so first let me write this down. Okay. So consider a system having n sites and the system has q particles. Now, these particles can have either upspin or downspin, right? The energy of interaction the energy of interaction is given by following expression, which is epsilon is equals to minus sigma minus omega into sigma square, where W is nothing but a positive W is a positive constant, and sigma is equal to +1 if up spin, and sigma is equal to -1 if down spin. Now we are again given if and 0 is the number of vacant locations, number of vacant location, and F is the number of molecules having upspin, and down is the number of part molecules having downspin. Number of molecules having downspin. Okay. We are also given that Q is the total spin of the system, that is and up plus and down, and M is equal to and up minus and down. So then find the following. The first part is number of microstates. Number of microstates, that is omega, and hence the entropy, sorry, and the entropy S. The second part is find the temperature of the system. Find the temperature temperature of the system. Part C is comment on the temperature calculated in part B. Comment on the temperature calculated in part B. Right, so this is the question, and a hint would be first try to this question is very similar to the previous question. In one of the previous question, the partition function was directly given, and we are asked to find the equation of state. Whereas here, the energy interaction has been given, and partition function has not been given. So a hint is you try to find a partition function, then try to identify in which ensemble it is, and once you know what ensemble it is, you know the corresponding equations from which you can calculate the pressure. Right. So the first part of which I will say is first try to find what is the partition function based on this formulation. Right. Based on this formulation, try to find what is the partition function. That's the first part. And then once you have the partition function, and then you try to identify in which ensemble it is. And once you know this partition function as well as ensemble, then you straight away have the formulas to calculate the pressure. Okay, so I'll give you, let's say, 5 minutes to attempt in trying to find the partition function of the system. Okay. I hope the question is clear to everyone. If you have any doubt, you can ask me. Okay, so let us move on to the solution. So we are given that Q is equals to N up plus N down, and M is equals to M1 is equal to N up minus N down, right? Therefore, N is equals to Q plus N0. It is equals to N up plus N down plus N0. The total energy is equals to E is what? Is equals to minus W into Q, right? Now what is sigma? What is sigma of the multiplicity is that the total number of ways of putting the molecules N up and N down molecules in N site. Total number of ways of putting N up molecules and N down molecules in site N. Right? Now considering particles are indistinguishable. Particles to be indistinguishable. Therefore, we can write multiplicity as sigma is equals to n factorial divided by n of factorial multiplied by n down factorial multiplied by n0 factorial. But remember that Q is equals to n up plus n down, and M is equals to n up minus n down. Therefore, n up is equals to half of Q plus M and n down is equals to half of Q minus M. Okay, is this clear to everyone? Okay, and then we have n0 equals to n minus Q. Putting these expressions in above equation, we get multiplicity equals to n factorial divided by half of q plus m factorial into half of q minus m factorial into n minus q factorial. Okay, and then we also know that entropy is equal to minus kb ln omega, right? Therefore, entropy is equal to minus kb into ln of n factorial. It's better if we go in the next page. Therefore, entropy is equal to minus kb into ln of n factorial divided by half of q plus m. So like this, half of q plus m factorial multiplied by half of q minus m factorial multiplied by n minus q factorial. Yeah. Now applying Stirling's approximation, we get ln n of, so what is Stirling's approximation? It is ln of n factorial is nothing but n ln minus n. Therefore, we get s is equal to minus kb. So basically, this becomes ln of n factorial minus ln of half of q plus n factorial minus ln of half of q minus m factorial plus ln of n minus q factorial. And s is going to be minus kb into n and then n minus n minus of half of q plus m into ln of half of q plus m plus half of q plus m. Okay, minus half of q minus m into ln of half of q minus m plus half of q minus m plus n minus q into ln of n minus q minus of n minus q. Is equals to minus kb upon simplifying, we get, let me use a different pen here, s is equals to n ln minus half of q into ln of half of q square minus m square minus half of m into ln of q minus m. Sorry, q plus m by q minus m. q plus m, q minus m. Yeah, right? This is it. Okay. Now we are going to assume let small q is equals to q by n and small m is equals to m by n, which implies q is equals to q into n and m is equals to m into n. Right? Therefore, integration becomes minus kb and ln of n minus n into ln of half of n square q square minus n square m square minus half of mn into ln of q plus m by q minus m. Eventually, it becomes s is equals to s by n, which is nothing but small s, is equals to minus abq into ln of half of square root of q square minus m square minus half of m ln of q plus m q plus m by q minus m minus of 1 minus q 1 minus q 1 minus q into ln of 1 minus q. This is the final expression. Right? I hope this is clear to everyone. So we'll just wait for a couple of minutes for everybody else to understand it. And then now we'll go to the next part. That is, what is the temperature? Once we have this, then we know, most likely we know that what is going to be the temperature. So I'll just wait for a couple of minutes for you guys to understand. So I think we can move on to the next part. Okay, now which is how to calculate the temperature. Now part B. We know from fundamental equation that 1 by T is equal to 2S or dou S by dou E at constant M. Dou S by dou at constant M. Right? Therefore, 1 by T is equal to minus 1 by W into dou S by dou Q at M, where M equal to constant. Right? In intensive form, we can write 1 by T is equal to minus 1 by W into dou S by dou Q at M, where S equals to capital S by N, small q is equal to capital Q by N. Right? Therefore, 1 by T is equal to what? 1 by W into dou by dou Q by minus KBQ, dou by dou Q by minus KBQ into half of ln of square root of Q square minus M square, right? Minus 1 by 2 M into ln of Q plus M divided by Q minus M minus 1 minus Q into ln of 1 minus Q. Therefore, 1 by T is equal to 1 by W into ln of 1 minus Q minus 1 by W into ln of 1 by 2 into square root of Q square minus M square. Right? Therefore, upon simplifying, we get just 1 minute. Yeah. Therefore, upon simplifying, what we get is 1 by T is equal to W by KB divided by ln of 2 into 1 minus Q divided by square root of Q square minus M square. W by KB. Right? I hope this is clear to everyone. If you have any doubt, you can ask. Okay. Now we will move on to the part C. Okay. So note that Q is between 0 and 1 and M is between minus Q and plus Q, and W is equals to positive value. Therefore, there are two possibilities for ln to exist. Ln of 2 into 1 minus Q square root of Q square minus M square exists if can be negative or it can be positive. Therefore, 1 by T is equals to positive quantity divided by positive quantity, or 1 by T can be positive quantity divided by negative quantity. Therefore, 1 by T can be negative, which implies temperature can be negative. Now, let me summarize the key results. So, key results for part A is what is the partition function? Oh, sorry, what is the multiplicity, right? So we find that multiplicity is going to be n factorial divided by half of q plus m factorial multiplied by half of q minus m factorial multiplied by n minus q factorial, right? Similarly, entropy by n, the intrinsic property of entropy was kbq into ln of, or it should be like this, kb into q minus q into ln of half of square root of q square minus m square minus half of m into ln of q plus m by q minus m minus of 1 minus q into ln of 1 minus q, right? Further, for part B, we found that temperature 1 by temperature was equal to W W by KB divided by ln of 2 into 1 minus q divided by square root of q square minus m square, or T is equals to ln of 2 into 1 minus q divided by square root of q square minus m square divided by W by q, W by kBT. And for the third time, we found that temperature can be negative for this system, which is a very shocking news, right? So I hope that this is clear to everyone. So I'll wait for a couple of minutes if anybody has any doubt in whatever we have studied till now. Okay. So in essentially what we have studied, we have started for today's class with introduction to by solving some problems related to the equations of motion, both Hamiltonian as well as Lagrangian equation of motion. Then we studied about we solved some problems related to lattice model. How to find the partition function if the description of the system has been given, and from that partition function, how do we calculate the other properties such as equation state or temperature or pressure. So we have covered that one. So I thank you all for attending this class, and I hope that you have enjoyed this class and whatever problems we have solved today. Can we will make you solve the assignment problems in an easy manner. Okay. So I thank you all for attending this class, and I hope to see you all again in the next class. Thank you.